Hi, I'm Jamie with Chegg Tutors. Today I want to walk you through how we can interpret coordinates on the unit circle. In other words, the circle in the coordinate plane centered at the origin and with radius 1. Here, it has a radius of more than one of these boxes, but I figured it'd be easier to see this way. I'll walk you through the steps here. So first of all, why do we care about the unit circle? Well, this relates to trigonometry and to relating the angles in the center, here S, to the arc length. The first thing we want to note is that the arc length here is the same as the angle because angle in radians, because a radian is simply the arc length of an angle S on the unit circle. That's how it's defined. So firstly, we want to work with the unit circle in units of radians most of the time and not degrees. That's where you see this conversion here. 90 degrees is pi over 2 radians. Just to refresh also, this entire circle is 2 pi radians, or 4 pi or 6 pi, any multiple of 2 pi, because the circumference of this unit circle, 2 pi r, is simply 2 pi with a radius 1. So how does this relate to trigonometry? Well, if I take this angle S, because the hypotenuse, the vector here, has length 1, because it's a radius of the unit circle, the cosine, say, of angle S is the x-coordinate here divided by 1, which is just the x-coordinate. That means that the x-coordinate of this line that defines the triangle for angle S is simply cosine of S. The y-coordinate, similarly, is the opposite over the adjacent. Again, the opposite, over the hypotenuse. Again, the hypotenuse is 1, so this y-coordinate of S, the point where, or the y-coordinate of this point where you have arc length S, or where the angle S intersects the unit circle, is sine of S. Why is this important? This gives us a way to go from any real number between 0 and 2 pi to a corresponding point on the unit circle simply with trigonometry. We take the cosine of that number and the sine of that number. We mark that point on our xy coordinates, and that is our point on the unit circle. Now it's important to remember that we can define this for any real number simply by subtracting 2 pi or subtracting the nearest multiple of 2 pi enough times so that we get the actual number. If we wanted to be really sticklers about it, something like 3 pi would be one trip around the unit circle, one whole trip, which is 2 pi, plus a half trip, which is pi. We'd end up over here for a unit of 3 pi. Now the other reason that the unit circle is important in trigonometry is that we can actually use it to extend our definition of sine and cosine to any real number. Now there are other ways of doing it, but this is probably the first way you'll encounter to extend the definition of sine and cosine beyond right triangles to any real number. Now the way we do that is by noticing that for any number less than 90, any radians less than pi over 2, we can draw this picture like we just derived, where the cosine of the number between 0 and pi over 2 is the x-coordinate on the unit circle, and the sine is the y-coordinate on the unit circle. Now we can then define the point on the unit circle that corresponds to any given real number by saying, well, if I have a number that's greater than pi over 2, I'm going to say the cosine of that number is the x-coordinate of the point on the unit circle that it corresponds to, and the sine of that number is simply the y-coordinate of the point on the unit circle that it corresponds to. This gets us wacky things like negative values for sine and cosine. Here we'd have negative values of cosine and positive values of sine. Here we'd have negative values of both and positive values of tangent, etc. So this gives us a way to move from trigonometry being just about right triangles to trigonometry helping us with real numbers in general. Now just to finish off, I want to close with a couple of examples of how we can actually calculate this and check that this unit circle representation actually works. So for example, at 90 degrees, which is pi over 2 radians, we rotate again, counterclockwise is the convention, around the unit circle. We hit pi over 2 radians at 90 degrees x-axis, which is simply over here. It's the point x-coordinate 0, y-coordinate 1. Now let's check this. The cosine of 90 degrees is indeed 0. The The sine of 90 degrees is indeed 1, so this works out. If we look at the point 1, 0, x-coordinate 0, y-coordinate 1, take a second to think about what this x-coordinate will correspond to, and what about this y-coordinate, and see if it works out. Got it? So, the x-coordinate is going to be the cosine of 0 degrees, or 0 radians, and we know that the cosine of 0 is 1. Y-coordinate, sine of 0 radians, also going to be 0. So this checks out, and you can use that kind of is a very informal proof. What we did with the cosine and sine with this triangle is a more formal proof, but this gives you some intuition into how the unit circle works. Hope this was helpful. See you next time.